proceed to the fourth speaker. Dr. Tony Pérez will present RSS and sensor fusion algorithms for indoor location systems on smartphones.
I am going to talk about positioning in indoor environments. So I will show you a little bit about the context, what is indoor positioning, and the two techniques that we will be used, Wi-Fi fingerprinting and sensor fusion. Then the tests we developed and our conclusions. Well, the context is that all of you probably know about the importance of position. All of you have very location-based systems in your mobiles and context-aware recommender systems. All of them need location. And about location, there are three things very important: fast coverage, precision, and security. We will talk here only about coverage. Well, outside, it is very easy to position people. Well, easy. We have several GNSS. The more known is Galileo and probably GPS. And they only work outside. Well, but what happened inside? Probably if you want Hansel and Gretel to get lost, you should have to take them inside the building, not outside, because nowadays it is very easy to position outside. And how can we get the position inside? Well, we have many things, many ways to do that, but we have three very important restrictions. We only want to use infrastructures already present in the building. We want to be very easy pass from outside to inside, and also we want an end-user application. An end-user application that have to work in a smartphone without internet connection. Well, why without internet connection? Because if you see the map of Catalonia, for example, you see that the green zones that there is internet coverage are very few. Actually, if you live abroad outside of Barcelona of the high velocity speed trains, you don't have coverage. And what happens if you need an end user? We need an application that has to be very fast because you probably want to stay a long time waiting for the response of the application, and it has to be very easy to use. Well, let's see how can we do indoor positioning. There are many ways. We can use markers, we can use wireless systems, and inertial systems. The markers are not a true indoor positioning system. The markers are, well, you are here. Well, I already knew that. But then we don't use that. So we can use also signal. We have many signal devices, Wi-Fi, RFID, Bluetooth, but signal needs a device to receive the signal. And also the inertial systems that you have a sensor, and with that sensor and that information, only with that, you are able to get positioning. Well, let's see what will we use. Well, markers at a fake, then we will use it. That we will use wireless. And which wireless? Wi-Fi, because there are already the sensors of Wi-Fi, and inertial systems. All of them things that we can find in every smartphone. So how can we get positioning with Wi-Fi? With Wi-Fi fingerprinting. It has the more common way to use it, and there are two steps in doing that: calibration and location. For making the calibration, you have to go with your smartphone to take a run of all the building and take signals of every single point. In every single point, you will find a lot of Wi-Fis, and with a level of every Wi-Fi. You can take the signal several times. You take apply the formula. We use mathematics, of course, and then you can make the mean and the standard deviation. After that, you take only the more stable Wi-Fi signals. You don't take all of them. And after that, since you want a very fast application, you take only some of them, some of the measures you took. Well, then you could build the calibration matrix, and with this thing, make it in every single point, you can get the map of signals of your building. Then the next step is to make the location. The location is exactly the same. You take the signal in every single point, and after that, you compare. It doesn't work. Sorry, because it is a technical. And after that, you compare with all the places with the same signals. But only when you find the same the same access point. After that, you calculate the distance, but the distance not with the position, but with the signal level. So actually, it is not a true distance. And only of those points we have the same node. After that, you renormalize to take into account how many access points you use, and then, like a mean, you take the position. So then we were able to take the position with Wi-Fi. Let's see sensor fusion. Sensor fusion uses two sensors of the smartphone, accelerometer and magnetometer. Well, you know this formula probably. Well, all of you know this formula is the Newton formula of acceleration, and it is very useful, this formula, because when some barbarians talk about the utility of kinematics and Galilean physics, you can show this and show that this is useful to make location with smartphones. So it doesn't need more explanations, but if you apply Galilean physics, Galilean physics is not actually Galilean physics, we can talk a lot about that, but you can get the position only with a secondary formula. You know probably all these formulas, and after that you have a problem, because you can have your smartphone in many ways. People go with a smartphone in this way. Well, then you have to put the smartphone in the appropriate way. But we don't want users to do that. So there is a change of coordinate system that you can go from the reference system of the smartphone to the reference system of Earth. And after that, combining the accelerometer with the magnetometer and getting the orientation of the smartphone, you can get how can move the smartphone within Earth. Well, we have two systems to position indoor. Well, have we managed to get indoor positioning? Let's see. We made two tests. RSS and sensor fusion. We made the test with a common smartphone, and we first of all made the test in a flat, in a 120 quadrat meter flat in the center of Barcelona from a Becarian. So it is curious. But in all of the tests we made, we use 40 nodes, and we don't want to use more nodes because if we use more nodes, the application will be slower, and we don't want that. And after that, we have made 100 tests. Well, in a flat, we get a precision of 1.5 meters. But when we go to RSS test in Mediatek, 1,600 quadrat meter, then precision is slower because we have less nodes. So this is a problem, but it's actually a first approximation to our positioning. But what happens with sensor fusion? Well, it is absolutely fake. It is absolutely failure because sensors within the smartphone are of very low quality. So we are not able to get a very good position. It is actually can be done, but with better sensors. Well, so then actually from our tests, the only way to get our positioning within a smartphone is using Wi-Fi fingerprinting from the test we made. So our conclusion is that we have able to make an RSS and sensor fusion technique to get positioning. We have been able to get a good precision within small buildings. We are still working a lot in high buildings. Actually, we have a problem with sensor fusions. And what is important, I want you to know, is that all the techniques are totally within the smartphone and have the answer in less than 5 seconds. Well, if you work with your smartphone, you will see that 5 seconds is a long time. But more than the 5 seconds is a still longer time. So 5 seconds is pretty good. But what are we working now? We are working in getting better position. Of course, we want a precision of 1 millimeter. It is our goal. It is difficult, but you have to get good position, good goals. And we are working actually a lot in Z positioning. That it is actually a field that is totally new, and it is not still solved. So thank you very much, and hope you liked it.